problems that we saw yesterday, which were just general find the or solve the differential equation. So that's where we're starting off. Our first even was number 8. Number 8, I don't like exactly how they're showing their work because they're putting dx on both sides and then changing the y prime to be dy dx. You guys know up on the front board, I say make y prime dy dx, multiply the dx on the other side. You should have eventually, though, ended up right here, at which point, after solving the differential equations, anti-deriving both sides, getting y by itself, you end up with this e to the, that becomes a new constant c, and y equals. They did not give you a clue, though, so you couldn't go any further. They did not give you a clue, you couldn't go any further. This is the same thing as 1/2 x squared, by the way. Number 22 was an exponential growth. Is it growth? Is it growing? No, it's shrinking. Technically exponential decay. But either way, using this exponential equation, plugging and chugging, you guys would have ended up with either using the decimal or the expression ln of 1/8 over 5. We talked about how there are many different ways of writing that. So it depends on which one you use. But either way, 4 should have been your c, e to the this constant times t. This constant, whichever form, times t. Number 56 was a wordish problem, yeah? It was exponential, what was going on? Growth or decay? Growth this time, from 125 to 350. You would have had to use both of your clues and some substitution in order to, because you were missing k and c, so you could have solved for c and then plugged and chugged and then solved for k. You would have had to use some exponent rules if you had gone that way. But eventually you should have gotten k to equal either the decimal. Now guys, if you're like, I'm not sure if mine is the same thing, throw it in your calculator real quick and then compare. Because the decimals should match. Remember, logarithms can look differently sometimes. Logarithms can look differently sometimes. So if you want to check and see if you got the right k, you can plug in your constant in your calculator. And then they went ahead and found c by plugging k back in. And solving, and c ended up being 44.64. You guys should have left 3 decimal places there. That's nasty. But at the end of the day, you were actually doing whole numbers of bacteria, kind of like that one free response where it was like round to the whole number for the number of people. Was that people in the park or people in line for tickets or whatever that FRQ was in chapter 4? With all of those solved for, you guys should have been able to make your general equation for y, plug in for letter C, t was 8, and find the number of bacteria. And then letter D was setting the number of bacteria equal to 25,000 and using algebra to get t by itself. A couple more seconds if you guys are solving for any of that. But the key to this problem, being able to finish it, was having to find k and c, which actually basically came back to good old substitution. Having a system of equations, 2 unknowns, solve for one, plug into the other, use your algebra. Number 66 was actually kind of nice because it gave you a differential equation, and so you had to go ahead and rearrange. Here's our rearrangement. Here's where your integral should have ended up at, with the integral of y dy and the integral of 8x dx. Wasn't too bad. They're both just power rules. They gave you a so you go ahead and plug it in. C equaled -8. Well, check it. You might have actually gotten y by itself first and then solved for c. So maybe your c wasn't -8, but at the end of the day, did you end up with y equals plus or minus square root of 8x squared minus 16? So depending on where you did the c, if you guys notice, they actually solved for c before getting y by itself. They actually solved for c before getting y by itself. So then when they came down here, they were like, hey, y equals plus or minus, but here's the dilemma, kiddos. What was your clue? Y of 2 equals -4? Were you supposed to leave the plus or minus for this point? What did the y's end up being? At this point, the y is negative, so which y should I keep? The negative one. The negative one. They were looking at their clue and saying, hey, y of 2 is a negative 4, so therefore in this example, I'm supposed to be finding the exact solution that leads here. And the only one that leads here, even though the math, the general solution says plus or minus, in this case, where we're being plopped into our slope field, in this case, it's the negative square root, which is letter A. Oh, that was the last even. Let's go check the evens on section 5.3, and then we'll backtrack if you guys have questions. Section 5.3, remember, this one zoomed out and said big picture, differential equations. They can look all sorts of different ways. You guys can already start checking number 10's general solution. Number 18 is a particular solution because they gave you a clue. If you guys made a mistake on this one, if the mistake wasn't in organizing it, algebraically rearranging it, I bet the mistake was probably in your U sub. But hopefully you were able to get there. Now, you might have kept going and said y equals plus or minus square root. That wouldn't have necessarily been wrong. But in section 5.3, there were some places actually where it was impossible to get y totally by itself. There was one with a y cubed and plus or minus a y. We'll see if we see it today. But we get y by itself if we can, but we can't always get it by itself. So this one, they actually left it implicitly defined. They just left y squared, and they were like, forget it. But you could have done plus or minus square root. Number 18, rearranging, ended you right here. You could not have brought that 2 down, because it's not ln of x squared. It's ln of x squared. So this does not fit the logarithmic property. It's not the x that's being squared. It's the entire logarithm. So you would have had to keep it there. Some of you might have done illegal simplifying. But plugging in, you end at your particular solution. And then, whoa, I gave you tons of odds. The next one was number 78. I think I wanted you to check, huh? Number 78, the final answer is B, but you can see why. Let me give you a couple seconds on that one. And as I do, I think that's our last even. Guys, I am going to go ahead and give you a quick picture of the test review. I already have it scrolled. As soon as I unfreeze the screen, it'll be there. So if you want to grab out your phone and grab a quick picture, or if in your homework spiral, turn to the next page, you might want to write down the test review. This is what's due on Monday. It might seem kind of weird because I have 2 different pages. One of them is from the chapter review. One is from the chapter test. I actually liked some of these problems. I don't know if I'd say more than those problems, but I thought that these were very good practice. So that's why I gave you both. I realize there are some evens that I gave you in the chapter test because they were just good problems. However, in the back of the book, there are odds for every single homework assignment, but for the AP exam practice questions, which is where that page 404 is, they actually give the odds and the evens. I'll come right back to this in a sec. What I'm talking about is usually we do questions from the review, and I did give you the review. That's page 402. Those are these ones, the review exercises. But I also gave you some AP exam practice questions because these are just great multiple choice. But once again, in the back of the book, guys, the evens and the odds, there are answers for both on these types of problems. So don't worry, answers are in the back of the book, and don't worry, all the answers, including the evens, are in the back of the book. Okay, to that end, we're going to go ahead and go over as many questions as possible while still leaving some time for going to our practice test and working on FRQs. So if you need to come up and grab a book, if you didn't bring one and you're like, I don't have any questions, I just want to work on my test review, that's totally fine. If you want to work on your practice test, that's totally fine. But right now, what questions do we have? Let me actually write them on the board to keep myself organized. For section, let's start with section 5.2. Okay, section 5.2, call them out. What do we got? 33, what else? 67, what else? 41. 56. Okay, section 5.3, what do we got? 29. 25. 70 what? 79? 37? Okay. If you guys notice, we have a lot of questions, yeah? I would love to answer some. However, I think some of you can answer some and get participation points in the process and show really good work to explain to people just by your work how you got them. So are there any of you out there that are like, psh, I can take that one? AJ, which one? 67. When you come up to the board, just grab a marker. I have, let's not do little markers. Let's do big markers. Let me get this box out. Grab a marker. AJ, just since you were the first one, go ahead and erase that whole board except for the CalcBC senior count. That's totally fine. We'll leave that up. Erase the whole board. And when you do your problem, put the section and the number. Is that cool, guys? Put the section and the number and then go. So AJ is 67. What else do we have? Brian?
I'll do 37.
37. Got it. What else do we have? Yeah. 25. Okay. I think all three of you should be able to fit up on that board. 2 of you on the right-hand side, 1 of you on the left. Okay. Patricia, I'll put you right here. I'll go ahead and erase this because I'm reading this. I can do some too. I'm just trying to give you guys a chance. And it saves us a little bit of time. Any other ones we can do? None at all? Okay, let me see what we're doing. Number 33, number 41, number 56. Oh. And number 79. Okay, I'm going to start Allie.
Oh, I also have another one for 5.2.
What do you got?
13.
13? Did someone take 13 on 5.2? Huh. Okay, then I'm going to go ahead and start putting people in pairs to go ahead and solve. Now, number 13 is a slope field one. The picture's going to probably be helpful on that one, so I'll go ahead and steal number 13. Number 56. Well, 56 not too bad, just the clues are a little bit tricky. 41, 33, 79. 79 was a little bit messy. It was a multiple choicey one. So let's go ahead and get some pairs working on number 56 and 79. 33 and 41, I get were in the table, and some of you guys didn't like the table, so I'll go ahead and steal those ones along with number 13. But number 56, let me go ahead and get Eurus and Janelle. I'm going to put your two brains together on number 56 just to show me how far you combined can get on it. Okay, just to show me how far you combined can get on it. And then for number 79, I'm going to go ahead and get Grace and Rebecca. I'm going to put you guys on these boards. If nothing else, you guys can go ahead and write down the givens and then like A, B, and C, the finds on those two. But let me go ahead and get you guys half on this part of the board, half on this part of the board. We'll go ahead and get 56 and then 79. And you guys working together get as much information as you can on those two. Okay, so 5.2, 56. And then 5.3, number 79. Here we go. And then I'll take the other ones. All right, go ahead, kiddos. I'm going to go ahead and pause the recording because I'm going to get set up for the other ones that I'm going to take. And then we'll go from there. up on the screen just because my webcam's behind the whiteboard right now. But for letter A, it was just saying follow the flow a couple times. We can look at that in a second. But letter B goes ahead and says use integration to find the particular through the point that's given. And then use a graphing utility to actually graph it and compare with what you sketched as your flow and what matches up. So for this one, you guys know what I would do, right? The very first thing is multiply the dx. And as soon as I have my dx, my dy is established, my dx is established. I know this is the y side, this is the x side. And so then I can go ahead and say I need to keep the x there, but I need to divide the 1 over 6 minus y. So once I multiply my dx, then I go ahead and establish the sides of here are the y's, here are the x's, let's go. So I rearrange it appropriately and it's time to integrate. This one would be fairly easy in the sense of I can integrate antiderive right away. But over here, I am going to have to do a little bit of u sub. U is 6 minus y, du is equal to negative dy, which means dy is equal to negative du. With that, I'm able to, let's move this down, rewrite this as the integral of 1 over u, and then if I'm plugging in, I have a negative du. So I need to go ahead and integrate that to be negative ln of whoever u is, which is 6 minus y, equals 1/2 x squared plus c. You guys might have seen in CalcChat or even when we were looking at the evens today, we do have an option. We have an option of getting y by itself first, which is what I showed up on the board yesterday with my little steps for finding solutions to differential equations. Or we could actually plug and chug this guy right now in. Typically, I do tend to prefer trying to get y by itself first. That's just my natural bent. Maybe that's good, maybe that's bad. We'll see when we get into some AP free response as to how that works. But if possible, I do like doing that first. So I would move the negative to the other side, get ln of 6 minus y equals, multiplying by a negative, I end up with negative 1/2 x squared. I could call that a c1, and then I have minus c1 can be a new plus c. I would need to do e to both sides. Remember, this whole thing is my exponent now. I am able to get my absolute value of 6 minus y equals. Technically, I could call this c2 if I want, and then I could make a new c times in front based on all the work that we showed over the last couple days, or last few days. At this point, we could go ahead and think of the absolute value and how the absolute value can equal a plus or minus c, depending on our domain restrictions, in which case our c could technically kind of absorb that plus or minus and be a new constant. We could go ahead and add the y and subtract the rest, getting y equals 6 minus c e to the negative 1/2 x squared. We could actually make this plus another arbitrary constant, but whatever. It's all right. At this point, I'm going to bring in that clue from up above, which I think was 0, 0. Is that right? So y is going to equal 0 when x is equal to 0. That makes that whole thing 0. E to the 0 is 1. 6 minus c needs to be 0, which means c is equal to 6. So I can end off with my final equation of y equals 6 minus 6 e to the negative 1/2 x squared. At which point we could go ahead and get a sketch of that in our slope field, because we could just graph that y equals in our calculator and then see if it follows the flow. But without the picture of the slope field, it's a little confusing. Remember, once again, number 13, it might be that their explanation wasn't good, but you should have been checking out that video definitely as far as their process and seeing if it makes sense, seeing if it helped expand your understanding of the problem and of the solution and how to solve. You guys probably have the answer right there, but I'm going ahead and checking it. 6 minus 6 e to the negative x squared over 2, which is negative 1 x squared. Yeah, that's good. Okay, but moving on to number 31. Let's just look at them. Why do you like them? Yeah, it's in the table. I'm guessing that's probably why. And you weren't a huge exactly what was going on. Was given to you, but both of them are exponential growth or decay. We can start with the exact equation, just realizing since this is half, that k needs to be a number eventually. And since this guy is double, but the nice thing is exponential, it's following that. Etc. But as we go ahead to try to plug in these, remember how I said half-life is at, not equaling 1. And the same thing as the ratio y of t over y sub not equaling. Up here, could take a yellow box of you needing to know that for ooh, that's a 5. And as soon as I know that, kiddos, I know my equation. My equation is y of t equals initial 5 grams times e to the, my constant, 1 over 5,715 ln of 1/2 times t. And if that's my equation for number 33, well then if it says after 1,000 years, don't we just plug in t as 1,000? So to finish off, what to do is say, okay, plug in 1,000. Okay, plug in 10,000. Got them, coach. Label them with green. You're done. Instead of setting my ratio equal half, it's not. Oh, wait a minute, but they told me. Oh. So therefore I can go ahead and say that e to the 7 3/4 t is equal to 2. Or I could solve and say t is equal to divided by 7.75. Got him. Sorry, not t. That was t. Who's the guy? Yeah, that was. I don't know. Chemistry and say, okay, half-life, ln of 1/2, 1 over the time it takes. So we can go ahead and say we know our y of t because they gave us our initial, which was super nice, 750. E to the 1 over 7.75 ln of 2 times t. And then guys, aren't you just filling in a table again? Any constant? Find that as a decimal, make it into a percentage. And then the next part is amount after 10 years. You have to plug in 10. Got him, coach. Okay, give me a thumbs up if you're like, yep. Cool. Now, you could have actually gone back to pre-cal and you could have realized there's like a snazzy formula that's principal e to the RT. Like, you could have done that, but it's actually okay, whatever. Exponential growth and decay amount equation, population equation. With that, let's go ahead and see what's going on over here, because section 5.2, number 56 was harder. Why was 56 harder? Did they give you the initial amount? Nope. That's what was sad. So in this one, I gave you the amount left after 2, which is 125. Minutes or months, or what were they measuring in for this example? Huh? Oh, hours. Okay. So then after 2, back to after 20 back to oh, this is why cold flu season is so bad. Anyway, so coming back, head and exactly what I would have done. They started off with their general equation for exponential growth and decay. In this case, that bacteria are growing. Oh man, they're growing. They went ahead and plugged in what they knew. So y was 125 when t was 2, y was 350 when t was 4. This is a little baby system of equations, and we thought in the evens, and I was kind of talking about it. Guys, this is algebra. If you have 2 equations and 2 unknowns, you should be able to solve. In order to solve, you have options. You could go trying to get k and plug in for k, which looks super hard, or you could go looking for c. Now, they went ahead and were creative about it. You could have gone looking for c by dividing e to the 2k and then plugging and chugging. That's what the book did. That's what the answer key did. But they did it another way. They did elimination. But with elimination, subtraction and addition would not have eliminated anything. What would eliminate something is division. Instead of adding both equations, instead of subtracting both equations, like old school system of equations, they divided both. Why? Because 125 over 350, oh, you guys divided the other way. That's okay. Hold on. Lo siento. They divided the 350 equation, which is c e to the 4k, by the 125 equation, which is c e to the 2k. And this is actually a pre-cal trick that we talked about when solving exponential equations. You can divide whole equations, and when you do that, what happens to the c? Gone. And then what do you do with like bases with exponents? Subtract. So 4k is 2k is e to the 2k equals 350 over 125. Once they combined that e to the 2k, they had to get rid of the e. So ln both sides. Got them. Divide by 2. Oh, and they got a decimal. But then divide by 2, divide by 2. And then they got their k to be 0.515. And once they got their k to be 0.515, then they were able to plug in their k. They just chose one of these equations. I think they chose the top one. Plugging in k is 0.515. Maybe it would have been better if you plugged in the whole decimal, which you might have done in your calculator. Multiplied by 2. You can divide that e to the other side. They got c to be 45. They rounded to the nearest whole number since it's a number of bacteria. And then they were able to say, booyah, I got my equation. Hey, I can figure out when t equals 8 just by plugging and chugging. The one I would have changed is stuff like labels. But you guys totally got the hours down below. On this one, they set y equal to 25,000, divided by 45, ln both sides, and solved. You guys totally finished that puppy up. So good job. But up here, you could have, system of equations, you could have solved for c by dividing and plugged in, or you could do the cool division-y trick. Both of them eventually get you to your k, that can get you to your c, and then you have what you need. Section 5.3 is where we went next. Number 67 is up on the board, I think. How similar was 67 to number 56? Pretty similar. Equation. But on number 67, what was nice is that they gave you an initial, so it actually gave you your c right away. So you were able to find your k pretty quickly by plugging in both your c and then plugging in one more clue, which is how they got to k as ln of 5 all over 4. Which could technically Oh, this might be a little sad. Once you have your C and once you have your K, this allows you to say, oh, it was exponential growing. So y equals C e to the K. So did her integration to show true. But technically, with the two clues, you actually could have just gone straight and put in just the equation and asking you to solve the differential equation. Yeah. Actually, extra work, AJ, but it was good. Integration shows that it works, but also plugging in the clues shows that it works. Okay, section 5.3. Section 5.3, the questions that we had. You guys can see them on the board. What are we still stuck on? Number 79? Okay, so number 7 is a multiple choice, yeah? And in that equation, they rearrange and divide and keep x squared where it was. They multiply the dx appropriately first. ln of y minus 4. I would have done a little u sub to make sure, but you guys are right. Integrating 1 over x squared, you have x to the negative 2 power. You add 1 and divide by negative 1. I agree. We got e to the sides, which is totally cool. You can make the e to the c a new. That's totally cool. The absolute value, plus or minus, can get absorbed into the c, which is totally cool. I gave us clues. When x is 3, y equals 0. Just a few of you have issues reading function notation. So then they plugged in y is 0 when x is. Subtracting the 4, dividing by e to the negative 1/3. Wait, subtracting the 4. Dividing by, hold on. Dividing by e to the 1/3. Subtract the 4, divide by e to the negative 1/3. That would end up being, if you have negative 4 over e to the negative 1/3, what can we do with a negative exponent, guys? Can't we rewrite it as a positive exponent? So then with a positive exponent, e to the positive 1/3. And then you're plugging into your general equation, which would be x. There we go. And then when we have like bases, just trying to think of how to get this a little bit more put together. We could have actually put those like bases together by adding, but I guess we could leave them separate. What else does 79 ask us? Are we supposed to read it in a snazzy way? Oh, got it. Limit as x. So now I agree with the general solution. No, this particular solution. Sorry, you plugged in a point. Okay. And then letter B says go ahead and take the limit x of, write this guy just a little bit. So this would be e to the negative 4. Guys, if I'm taking a limit, it's as x approaches infinity. My x. Okay, look at this baby fraction. Just zoom in on this right here. It's the only place x is. If can't I say that this is going to end up equaling negative 4 cubed root of e all over e to the 0 plus 4? What's anything to the 0? Just 1. So then I would end up negative 4 cubed root of e plus 4, which I guess could also be something like 4 times 1 minus the cubed root of e, if you wanted to rewrite it. But I think I have my odds right here in the back of the book, number 79, as a response, so you guys couldn't have made it match. Negative 4e to the 1/3. They didn't even write the cubed root. Okay, cool. I guess you didn't have to write the cubed root. That's fine. There you go. To the 1/3. Got him, coach. Okay. Whew! We made it through 5-2, 5-3 questions. Some of you guys need a picture of the board. I'm going to go ahead and pull out the board so you can see it. People who are on the video right now because you were gone today, can I have someone with Thomas's number? He's the only one that ended up being absent today. Text him pictures of the homework problems on the boards. He can see the ones that he did. Just can't see solutions that are around the room. Volunteer, sorry to do that. You guys need to grab for that. Answers for Thomas, and then if you still need them. What did we not get to look at today? Okay, so right here in our notes, there are 2 different FRQs that I would have loved to have gone through with you. Number 6A is solving a differential equation by rearranging. Not anything crazy, not anything new. The first FRQ. Letter B says find domain and range, which is a little weird. The next one, number 5, once again, is finding the particular solution, and then it talks about tangent lines, which are kind of funny. Here's what we're going to aim for on Monday. The whole practice test isn't due, it's bonus. However, these are the 2 that I really want to go over with you in class. So Monday, when I'm going to go back here and update your board, I'm going to go ahead and have your test review due on Monday. Attempted, okay? Not graded. Don't worry about going online and trying to find an answer key and see what you did, see what you didn't do. But for Monday, the book test review and these 2 FRQs attempted, if I were you, I would set yourselves a timer for like 15 minutes and not let yourselves spend any more time than 15 minutes on either one. Some of you might even want to set the timer for 10 minutes because these are supposed to go quickly. All right, guys, I'll see you later. Thank you, thank you, thank you. Test review on the book and these 2 FRQs. Just talk about them on Monday. Just try them, and we'll talk about them on Monday. Bye, guys.